Okay, so Portuguese man living 11 years in Finland and working about 10 years in this construction industry. And today I'm going to talk a bit about this, how automation and technology can change some of the problems that we are facing in our industry. So first I talk a bit about Sweco. So Sweco is a consulting company that does design, mainly design. So that's why I focus today's presentation a lot on the design side of things. So we have about 15,000 people, and we do design projects for all these areas in the AEC business. All right. So if we jump into the issues in our industry, so we are sitting in a gigantic industry. So construction industry, it sells about $10 trillion per year. That represents about 11% of the global GDP, and it employs about 7% of the world's population. So it's quite a big industry. So we have some issues, some known issues in our industry. So the productivity has been, for the last 20 years, growing quite low compared to the other industries, so about 1%, and nowadays it's even decreasing. It's also known that in our industry, the amount of waste is estimated to be about 57% compared to the 12% in the manufacturing industry. So it's a huge amount of waste. Of course, there's a lot of possibilities to make things better. Then in the investment in R&D is also quite poor compared to the other industries. So in average, we invest about 1% of our profits in R&D and to make things better. And then this is something that happens at least in the Nordic region, and this is a statement from our CEO last year that our salaries are growing faster than the fees we are charging from the clients. So if we map these problems in this kind of formula, so the salaries are growing faster than the fees, we have low productivity, and we don't invest enough in innovation, then we should be having quite bad profits. So why does Sweco and companies like Sweco are still making profit? And why are they, in the last 2 years, for example, having the best profits ever? And the answer is quite complex, but I believe that the reason for that is our strong investment in innovation and development. And that is directly impacting our productivity. So we are more productive by the use of this technology. And that's why we are doing quite good results. And today I'm going to show you some examples of what we do in Sweco that are trying to make this happen. So I'll start I give you 2 examples today. Sorry for the poor choice of colors. So I'll start with the innovation. So innovation is doing the same things a bit better from before. And I'll give you an example of design automation tools that we have been building and our designers are using. So we achieve higher productivity and quality in our design. And then I'll jump to the disruption side. And in here, I'll talk a bit about artificial intelligence. And basically, disruption means that we are doing things that make the old ways obsolete. Okay, so in the innovation side, in the design automation tools, so basically, Sweco is doing design work. So we design buildings, roads, bridges, etc. So we use BIM software. So we make BIM models. So in here you see an example of a concrete structure. There's a column in the beam, and the users need to detail these structures. So we build this kind of design automation tools to speed up the design. So it speeds up the design and it increases the quality because it's done always the same way. And we have been doing about 160 of these tools in the last 5 years. Then another thing we have done was to start collecting information of who is using the tools and how much they are using the tools. So we know now in Sweco how many users are using each tool and so on. And then another thing we did was to try to measure the benefits of these design automation tools. So we put a couple of designers for like a week to do the old way. So in the left side, you see the old way. They did it by hand. So this video shows you how to detail a precast wall element. So in the old way, they did everything by hand, and now they have a tool that makes it much faster. So we measure the speed increase by the using of the tools. So in this case, it takes about 4.5 minutes we gain by using tools. This is an automation tools. And if you see last year, there has been 233 users using it. They have used it 110,000 times. So they have saved about 4,200 hours by using this kind of design automation tools. If I map all the tools together, so let's look at the blue lines. They are the cumulative result. So in the last 5 years, we have saved about 49,000 hours because we are using this kind of design automation tools. So this is the reason that we in the Nordics, even though we have a higher fees than normal, we still are competitive because we are able to do things fast and create a good quality. Okay. Now we go to the disruption side. So what have we been doing in this artificial intelligence? So some of the speakers already said today that data is very important, and I totally agree. And one thing that I would like to mention is that now in the world, the amount of data is doubling every 18 months. So every 18 months, we double the amount of data we have in the world. IBM is predicting that in a couple of years, we'll be doubling the amount of data every 12 hours. So we have lots and lots of data. And Sweco is one of the companies that has been collecting data for a long time. So we have thousands of BIM models, tens of thousands of BIM models. We have designers that are doing design every day. They are producing data every day. So the idea here is that we use this data to try to improve the process, to try to change the way we do things. So we improve the efficiency, the quality, and this also allows us to create new business opportunities and explore options that were not possible in the past. So this just lists you a couple of examples of what we have been doing. So we analyze the actions inside the BIM software. So when a designer inserts a column or a beam, or it makes a connection there, we are collecting all that information, and we analyze all that information together and try to extract reasonable data out of that. And then we are analyzing historical data. So normally, when you go to a new project, you don't look at what you have done in the past. You might have done 20 same projects in the past, but you don't look at them, and you don't learn from them. So we try to look at that historical data and get knowledge from that. And of course, then, using these two types of data, we are teaching the machine how to do design or to guide our engineers how to do design. And then when the machine starts to understand what it is to be doing design, then it can start predicting problems and preventing them. So now I'll give you some real examples of what the work we have been doing. So this is called Markov Chain. So the basic idea behind in this exercise was to try to see if we can predict the next action the user is taking. So this is the same algorithms that Google and Netflix are using to try to predict what the users of their services are going to do. So we try to apply the same approach to the construction industry. And we are getting good results. And the idea here is that we will never be able to automate everything. But the machine can read so much data that we can find these kind of specific spots that we can automate. And then we can save 10% of the time. And when you multiply 10% of the time by like 4,000 Revit users in Sweco, it's huge gains. Then another example or another exercise was to use this kind of deep learning, imaging recognition type of machine learning algorithms. So here we try to simulate the human brain, and we try to teach this artificial brain how to recognize building types. So we feed the machine with this kind of picture of the model, and then it runs through the brain, and then it tells us what kind of building it is. Is it an apartment building, industrial building, or any other type of building? And the success rate here has been about 96%. But this is just a simple exercise. The basic idea behind this could be that the BIM data or the BIM models, they are not perfect. Many times they are missing data. So can we use this kind of methods to try to extract missing data or try to find out what the missing data is from the model and then predict what the missing data should have been. So this is, for example, a use case for this type of solution. Then the third example, this is, again, it's this deep learning, so faking the human brain. And the idea here is that we have these precast wall elements, and we have tens of thousands of these done in the past. So we group them together. So the machine is grouping them together. Then when a designer is building a new wall, the machine understands that, okay, this wall has some opening here, so I'll need to make some kind of reinforcement around it. I'll need to put some lifting hooks here based on the cluster that it's assigned to. So we have this kind of a, how to say, recommendation system for the user that gives recommendations to the user that is doing design at the moment with the data that was collected from the past. So this, of course, as you can imagine, saves a lot of time also in the design phase. Then the last example is another prototype that is now starting to be used in production, and this is to try to automate the detailing phase in design. So if you look at this picture, this shows you a small power plant, and usually it takes about 4,000 hours to design that structure. 1,000 hours is the basic design, 2,000 hours is the detailing phase, and 1,000 hours is the drawing phase. So 50% of the time is to design connections and put them in the model. So we want to make this smaller or get rid of it eventually. So we build a system that automatically recognizes the connections. So in this case, there was 696 structural connections. And then we are feeding existing models that are fully detailed. And the machine will learn those structures and the relations between those connections and the forces applied to those structures. And then it will automatically start putting connections to the model. So these are the results the machine is getting. 22% of these connections, they are the green dots in here. They are perfect matches. So it's exactly the same configuration that we got in the past models. 55% is possible match, which means that it's not exactly the same, but the force is applied to that place, and the connection that was done in the past is enough so that the building will not collapse. So we can use that connection there. And only 23% of the cases we didn't find any match. So basically 77% of the connections are automatically detailed in this project. And as you can imagine, this saves a lot of time in design. So now we can start thinking of higher level problems. We can try to change the way we do things. We can give better quality to our clients. So we can start, for example, if you think of this connection here, the machine will not give you an option. It will give you multiple options. So, and then the machine can analyze the whole building together. And let's say that we give 3 options to the client. We give a building that is optimized by amount of steel, so the less steel or the similar type of connections. So the factory doesn't want to have 20 different types of plates. They want only 2 because it's cheaper to make and it's easier. So let's optimize the building to have similar type of construction parts. Or let's, for example, optimize for cost. Let's get the cheapest possible building. So we can start having this kind of new approach to structural engineering, something that we couldn't do in the past because of lack of time, lack of money, and so on. Okay, so this is my last slide. So we have some troubles in the construction industry, but because the technology is growing so fast and things are getting easier and easier to do, we are using technology to do better design, to be more productive, more profitable, and to do things that we couldn't do in the past because we have now these new methods. Thank you.
Okay, a few questions from the audience. How long does it take to check automated calculations?
What does it mean, automated calculations? Sorry.
Ar galėtų klausimą uždavęs žmogus patikslinti, galbūt? Neprisipažįsta. Na, tiek to, tada pereikim prie... Okay, let's switch to the next question. What is the bigger benefit of tools you have mentioned? Quality or consistency or time saved?
I think it's a bit of all of them. So if you are talking about the automation tools, they give us better quality, and they are more consistent because they are done always the same way. It's a computer that does them. And then it's faster to use it, to design them, because the machine does it much faster than the human. So if you give a connection to be designed by 10 different structural engineers, you might get 10 different solutions. And then the factory is pissed off at us because they get so big differences in the connections. But with this kind of design automation tools, then you basically restrict the user of what they can do. You strip off the power from them. You give them, you have 3 options. You choose option 1, 2, or 3. Then it's easy to start out. It's easier for the manufacturers to then to optimize their processes, because they only need to build those 3 types. They don't need to build 100 types of connections. Hopefully this answered.
Okay, and one more question. What ratio of developers to structural engineers is maintained in Sweco? Is there some investigation in optimum ratio cost benefits?
Which question is that one?
Yeah, you can see it. Oh, that one, the first one.
So we have, at Sweco, we don't call ourselves developers, so we are a mixture, a hybrid of civil engineer and developer. So like 70% of the team is like a civil engineering people that know how to do software. And we have now in Finland and Sweden, we have 17 people doing this kind of development, and we do about 20,000 hours development. And then there's hubs of developers in other Sweco countries. So, and we are all like trying to collaborate together to try to improve the business as a whole.
It's okay. Thank you, Mr. Farinha.
Thank you.